Hi everyone, Brybon here, and I'm back with another video. And today we're going to bypass Windows Defender. We're going to get an executable by Windows Defender. So a little more red team. We did a video on Cobalt Strike disassembly. That's very blue team. So let's balance it out by doing a red demo. So what we're going to need for this, we're going to need a copy of Visual Studio. You can use the Community Edition. This is Visual Studio Community Edition right here. You'll need that. You're going to need a couple of other tools. Invisibility Cloak. Invisibility Cloak, very recent tool, about 2 months old. Really good for obfuscating solution files, which is what we're going to do here. And then Defender Check. And Defender Check lets us run Defender without running Defender, right? So we can check Defender signatures and see if we can slip by before running it against the real Defender. And then we need whatever tool we want to slip by Defender. In this case, I'm going to use Rubeus, Ghost Pack Rubeus, very famous tool, really cool for messing around with Kerberos and doing Kerberosting and ticket importation into Windows and all sorts of stuff. Very well fingerprinted tool though. This one tends to get really eaten by AV, and that's why I want to use it for the demo. Because if you can get this passed, you can get almost anything passed. So let's go ahead and start here. So the first thing we're going to need to clone down our Rubeus solution file and compile it, and then we'll run it against Defender just to show that it's being detected. So we'll go File, we'll do Clone Repository, back over here to GitHub. We're going to get the code straight from GitHub. We're going to go ahead and clone down a repo for Rubeus. So we'll clone it down. We'll give it a second here to download everything from GitHub. And this can take just a minute, but it's going to go ahead and put it into our repos. And that gives it the solution files that we need to be able to build this executable. All right, so Defender is off. So if we take a look at Defender over here, we can see real-time protection is off. We're only going to turn it back on at the very end of this demo when we're going to scan our file with Defender. And that will show that it'll get by regular real-time protection. Now, this is a cat and mouse game as well. This may not work on your system, may not work with newer versions of Defender, new signatures, but it works for now. And these kind of things are very cat and mouse. You have to find new ways of doing obfuscation, to find new ways to slip by Defender. But for those of you who are penetration testers, you're used to this game. So let's go ahead and we'll show just how to get an executable by Defender in a simple fashion. All right, so we should have our solution file now. And we can go open Rubeus. Actually, it's already open over here. Just didn't see it. So what we need to do, we're just going to go ahead and build the project. Well, let's open it first. We'll just go ahead and update to 4.8. And this is just whatever version of .NET that you're using to compile it. And then we're going to go build. So we'll build the solution. And that's going to build the debug version of Rubeus. And we see build started down here. And there we go. Rubeus executable is built. So if we go up here into our repos folder, and then we go into Rubeus, Rubeus again, bin, debug, and Rubeus executable should be right here. So this is a typical process for compiling something from GitHub or any, methodology where you would download a solution file and compile it. So I'm going to take this, I'm going to copy it to the desktop. So we'll put Rubeus down here on our desktop. And then I'm going to close Visual Studio. Go ahead and close it down. And that's because we're going to obfuscate this here in a minute. So I want the Visual Studio to be closed so I can run Invisibility Cloak against the solution file without those files being open. So what we're going to do now, just because to prove that Defender will eat this in a normal state, go ahead and turn on real-time protection. I'm going to right-click and choose Scan with Microsoft Defender. And we can say it immediately ate a copy of it, Kakao AMTB. Now notice what this says, because this is going to change as we're doing our scans with Defender. Go ahead and tell it to start actions. And it's going to delete this version of Rubeus. Once it does that, it should show clear, and then we'll turn it back off for the rest of the demo until we get to the very end. All right. So I'm going to go ahead and just turn real-time protection back off. We know it detected. Okay, so it's back off. We know it detected Rubeus. We know this version would be eaten by Defender. So let's start obfuscating our solution file to where it won't be eaten by Defender. Let me go ahead and get out of this directory just to make sure we're in the right place. And the very first tool we're going to use is Invisibility Cloak. So we're going to open our command line here. And this is a Python tool. You can run it from Windows Python. I typically prefer to run it from WSL, which is the embedded Ubuntu or whatever release you want to use within WSL. We're going to use Ubuntu for this one. So we'll go ahead and we'll CD into the desktop here. And then I'm going to just type in simple bash. That's going to take me into WSL. So now I'm on the desktop in WSL. And in here I have Invisibility Cloak. And we'll just run invisibility cloak.py. Let's go ahead and we'll do Python 3 here. Just let you see the output. Go, visibility cloak.py. And if you run it, you can see the different versions and ways you can do string obfuscation within a solution file. So we're gonna do reverse here. You can do ROT13 or base64. We're gonna start with reverse. Now I am finding that a lot of tools just need this. They don't have to do the additional steps that we're gonna do with Defender check and the additional obfuscation that we'll have to do. But we're gonna run this reverse now against our solution file, and we're gonna get a new version. We're gonna call it Hagrid, and then we're gonna compile Hagrid and see if Defender detects that. Let's go ahead and clear our screen. So we will now do Python 3, Invisibility Cloak, Invisibility Cloak.py. We're going to do mount C users Clint Barton here. This is our Clint Barton folder. And then we're going to do source, which is our source folder. We're going to do repos and Rubeus. So this is our Rubeus repo. We're going to give the name of the solution file, or the name we're going to change it to, actually. It's going to be Hagrid. So we're going to change Rubeus to Hagrid, just like that. And then we're going to give it reverse, just like we showed earlier. So we'll run this, and it didn't run right. Let's see, mount C users, Clint Barton, source, repos, Rubeus, and Hagrid reverse. Did I do something wrong? Oh, I didn't give it the -d. Okay. So we have to give it the directory with -d. So -d. So let me just clear the screen. I'll pull this full command back out, clear the screen so everyone can see it. Let's just clear. There we go. So it's going to be Python 3, Invisibility Cloak, D for directory, the name of what we want to change it to, and then the method we want to use, which we're going to use reverse. So this should work now. There we go. And it is searching through and performing obfuscation on the strings within the Rubeus solution file that we created. So now if we go back over here and we go into Rubeus, notice the solution file name has changed. It's no longer Rubeus. And this is so that AV vendors can't key in on the tool name, right? You want to give it a different name, something that is completely separate from what you originally started with. They can really use any kind of string that they want to key in on. So let's go ahead and we'll open our Hagrid solution now. And we'll compile this and we'll see how far we get. Now I have a feeling Defender's going to eat this too, because before it has on all the previous times I've tried this. But let's go ahead and we'll get this solution open. And there we go. Solution file for Hagrid is open. And now we'll build this. Now we see build started and project Hagrid, hagrid.exe is built. So now when we come over here and we go into Hagrid and we go into bin, debug, hagrid.exe, we'll take this over to our desktop right here. And then we'll run this against Defender check. And Defender check is going to let us check if Defender is going to catch this without actually having Defender turned on. So on my desktop, I precompiled Defender check, and I'm going to go to Defender check, and then I'm just going to give it the executable name. That's hagrid.exe, and let's see what it does. And it's going to analyze the file. So this allows us to run it without having to worry about Defender actually eating it and recompiling it every time. Now, sometimes this works first shot. Sometimes it doesn't. We may have to do a little bit more obfuscation, but we should be able to get through this in a little bit, a couple of tries, and we'll be able to get Defender by the Defender signatures. So it's analyzing it, and notice it still detects it as Cacao A MTB. So one of the things you want to do here is look through what it's detecting. And notice how many times you see a certain word. So in this case, we're seeing the word tickets constantly through here. So I have a feeling the signature is going to key on tickets. So if we go into our solution file now, and we open it up, and we will, let's go ahead and just make sure it's loaded. It is. And then we're going to do find and replace. So literally just find and replace. So we're going to go replace in files. And we're going to type in tickets. We'll just do ticket. And we'll replace it with token. Just anything. Anything that we know. Just realize when you do this, if you use the tool syntax and you type that word in, it's going to be the word you're putting in now. So if I'm typing in tickets from the command line, it would become tokens. So now we're going to do the entire solution. We're going to make sure that it matches all, and then we're going to replace all. So we're replacing all, we're performing the replace. And this can take a minute because it has to open all the different files. Find, ticket, just give it a yes there. And it's gone through all of the files in the solution. Notice 966 occurrences were replaced. So we've replaced the word ticket with token. So if they're using regex strings, which they should be, then we probably broke their detection regex for tickets. So now let's go ahead and build the solution again. So we'll build the solution. And it's going to go through the build progress. We're going to go back into our folder now. And just for safety's sake, because I know this is my second run, I'm going to rename this to Hagrid 2. So we have Hagrid 2 that we're now going to place on our desktop. So let's go ahead and do that. We'll place Hagrid 2 here on our desktop because we know this is our second run. And let's do Defender check again. We're going to do it on Hagrid 2 this time, and we're going to see if it gives us a different detection. So if we've done everything right, it should give us a different detection name here. So instead of Cacao A exclamation point MTB, it may be something else. So let's let it do its analysis. And there we go. And notice now it is detecting it as Cacao B. So it's different than what we had before. It is not Cacao A MTB, it's Cacao B. So that means we beat the first signature. So now we're looking for another signature here, right? There's probably multiple that identify something as common as Rubeus, right? This very storied hacking tool, been around for a long time. Well, so let's clear screen here. And we're going to take a look at what we would need to push this further through. So if we, actually, I shouldn't have cleared the screen there. Let's run it one more time just to get it back on the screen. But within Hagrid 2, there's also another regex that we're going to need to clear. That regex is looking for base 64. So most AV tools, whenever they see base 64, they're like, you're trying to hide something from us. So they'll key in on that. So notice down here, we're going to see base 64, right? We see some other things, but this is the thing, if I was an AV person, I would key into is base 64. And that could be another signature that's it's using multiple things to determine that this is Rubeus. But let's change base 64 now. So if we go up into our solution file, we're going to do another find and replace. Go edit, find and replace, place in files. So we're going to do base 64, and we're going to replace it with 64 base. Right? Simple change enough that we can still recognize what it is, but it will break their signature. So let's go replace all now. Windows CRLF, 89 occurrences replaced, and we'll click OK. And then we're going to build it again. So we'll build our solution. And let it go. Still. Okay, I don't think it was finished. So let's build it one more time. Failed our solution. Oh, I see. 264 base string doesn't work. So we need to do this a different way. So let's do replace in files. So we need to do 2 base 64 string needs to still be there. So we need to make sure that you need to make sure that 64 base is replaced with base 64. We have to work it backwards one more time. Place all. Let's make sure our solution builds now. Okay. It's throwing errors. All right, I see what happened. It's case sensitive. So now we want to replace this with base 64. I didn't find any. Oh, yes, I have to do base 64 to base 64. Make sure that function finds its build type. We'll build it again. Now it succeeded. So now we have to find a way to find that exact signature and ensure that we are. So this just says the word base64. So we just want the word base64. Oop. Go back into Defender here, or Visual Studio here. We're going to go Edit, Find and Replace, Find in Files. This time we're going to match whole word instead of everything. So only where base64 is standing on its own. So we'll find all now. We can take a look at where this exists. And right here, see this base64 token Kirby? This is where Defender is seeing it because we see base64 Kirby right here or close thereof. So we're going to match full word only now and try our find and replace. So go find and replace. And we're going to match whole word. We're going to go base64. We're going to replace that with 64 base again. We'll replace all. 27 occurrence is replaced. Now we're going to see if we can get it to build. So let's go ahead. We'll make sure it's in debug. We'll build one more time. Build our solution. And it succeeded this time. So now we should be able to take our version of Hagrid and copy to our desktop, run Defender check. We'll place Hagrid. We're going to rename it to Hagrid 3. Rename it to Hagrid 3. Bring it over here just to be in line with the others. And then we're going to run it against now Hagrid 3. So before we tripped KOB, we are pretty certain it was looking for base 64. So let's try Hagrid 3 and see if our obfuscation worked. And here we go, we're analyzing. And the binary looks good to go. So that means most likely we have now bypassed Defender. But first, before we even mess with this, let's make sure it still runs, right? We want a working binary. So if it doesn't work, then it's useless to us. But if it does work, then we're in business if it actually is by Defender. So we'll go ahead and run Hagrid 3, and there we go. And also notice, if you look really close, you're going to see some of the things we changed. So notice token 64 base instead of base 64. So if you look through the program, just make sure that wherever you would see the word token, you understand from your syntax usage that that was the word tickets. And this would have been base 64. So if you're not really familiar with the tool's usage, make sure you understand what you're changing when you're changing the solution file. But looks like we're actually good to go. So let's go ahead and run a real scan against Hagrid 3 here with Defender. So we'll go ahead, we'll turn Defender back on. Real-time protection is back on now. And then we're going to right-click on Hagrid 3. And we're going to choose Scan with Microsoft Defender and no current threats. So we've now slipped Rubeus by Defender. Now we've slipped it by the real-time detection. That does not mean that the cloud detection won't grab it. It also does not mean that it's going to slip by every AV. You need to check the AV that you're pen testing against or working against before you start your obfuscation. You really need some kind of lab like this where you have the AV that you're working against, whether it's CrowdStrike, whether it is Defender, whether it's any of the major AV vendors, Carbon Black. Whatever you're going to work against, you need a copy of that in your lab. You need to be able to experiment with a solution file, and you need to be able to try to slip by. Do not submit your binaries to VirusTotal. They work with virus signature vendors. They will change their signatures to match what you're doing. So be very careful with that. If you submit it to VirusTotal, consider it burned. You'll have to redo your obfuscation and start again. That's the beauty of being able to use tools like Defender Check, where I don't actually have to use Defender to scan. But that's it. We have slipped Defender by our AV, and this could be used in a pen test now, exactly like we wanted to. So a little more red team for this demo. Probably go back to a different a blue team demo for the next one for Cobalt Strike. We'll do the Cobalt Strike executable removal and C2 channel discovery. But I wanted to go a little red team just to offset the blue so we keep our purple mantra. So if you like this video, please subscribe, like, comment, all those things. It really helps my channel. So thank you very much. Have a great day.